Hi guys, this is Ms. Martinez, and in this video we are looking at solving right triangles. As a student, you want to be able to solve right triangles using our trig ratios, determine and memorize exact trig ratios for special angles. Those are the 30 degree, the 45 degree, and the 60 degree, and solve word problems involving right triangles. Let's get started. Solving for a side in a right triangle using trigonometry. Okay, so we can use trig ratios to find unknown sides in right triangles. In cases like this. Here, there's no way for us to know the measure of A and C. The Pythagorean theorem only works if you know two sides. If you know two sides, you could solve for the third, but if you only know one, it's not sufficient. And that's where our trig ratios come into play. So looking at this problem, let's find the measure of side A. What we'll need to do is determine which trig ratio to use. And how do we know which one? Okay, well let's identify here. What we're looking for is this side that I've highlighted, and it is adjacent to our given angle, which is 45 degrees. We know this side over here that I've just now highlighted, and that is opposite of my 45 degree angle. Okay, so what trig ratio deals with opposite and adjacent? That is your tangent. Tangent of angle B would be that opposite side over the adjacent. So let's plug this in, the information that we are given and what we're looking for. It's tangent of 45, and that would be equal to the ratio 1 over A. Okay, so we're solving for A. What we can do is tangent of 45, when you plug that into your calculator, it is 1. That's very nifty. Make sure right now that when you do that, that your degree, it's in degrees, it's not in radians. We'll work with radians a little while later, but if you get something other than 1, it's probably because it's in radians. So check your mode. Okay, but we still have an isolated A. We're going to cross multiply here. And when you do, you'll have 1 times A, which is really just A, equals 1 times 1, which is 1. So A is equal to 1. Side A is 1 unit long. Now let's find C. Now technically, because we know that A is 1 and side B is also 1, we could use the Pythagorean theorem, but I just want to show you this same approach a little bit more. So which trig ratio will we use? Well, we know this side, it is opposite of our given angle, and we know this is the side we're looking for, and it is the hypotenuse. Which trig ratio includes opposite and hypotenuse? That is the sine ratio. Sine of B would be opposite over hypotenuse. Okay, let's use our trig ratio, plugging in what we know and what we're looking for. Sine of 45 would be 0.7071 if you use your calculator to evaluate that. And again, we'll cross multiply, so it'll be C times that value equals 1. To get C by itself, you'll divide 1 by 0.7071, and that should give you that C is equal to 1.4142. Please check in your calculator that you can do this. It's really important that you're able to type this in. And if you're not, make a little note in the margin so I can help you. All right, now, just in those previous examples, we solved for sides. Well, what if you're looking for angle measures? What if you have something like this, where all you know is it's a right triangle, but you don't know any angle measures. And yeah, you could find the side, that unknown side, but there's no way to find A or B unless we use our trig ratios. So let me show you how that's done. It's kind of the same approach here. Say we were looking for angle A. What we know is this side here is 15. That is the opposite side. And we also know that this side is 17, and that is our hypotenuse. So if we're working with angle A, and we're looking at a ratio that's going to include the opposite and the hypotenuse, we're working with a sine ratio. Sine of, I'm so sorry, that should be sine of A is equal to the opposite over the hypotenuse. Okay, so when we substitute that in, sine A equals 15 over 17. And we're trying to solve for A. So that means you'd have to get rid of the sine. To do so, you take the inverse sine of each side. And that is that mysterious button that you've been looking at. Inverse sine of each side. That will remove the sine from the left-hand side, and typing that into your calculator, if you take inverse sine and then in the parentheses 15 divided by 17, it should give you 61.9 when you round. Let's do another like this. I'm sorry, no, we're not going to do another like that. We're going to look at a very special triangle here. This is your 30, 60, 90 triangle, and they show up so frequently. And as we continue our study of trigonometry, we're going to work with angles that are 30 and angles that are 60 and angles that are 90 a lot. And so this figure we're going to actually reference daily for the next couple months. So let's talk about it here. Sine of 30 would be 1/2. Cosine of 30 would be the square root of 3 over 2. And tangent of 30, when you rationalize, would be the square root of 3 over 3. And I just wanted to show you here. The 30, 60, 90 triangle is actually created by taking an equilateral triangle and slicing it in half. Do you see that? The dashed line. And then if you looked at that bottom, the side length of 1 and 1, that would make it 2. Equilateral triangles, every angle is 60. So that's kind of just a little glimpse of, okay, where does this triangle come from? Well, it's an equilateral triangle cut in half. Now from the other angle, 60, sine of 60 would be the square root of 3 over 2. Cosine of 60 would be 1/2. And tangent of 60 would just be the square root of 3. Now, do you see something here that's really fascinating? Look at these two ratios. They are equivalent. Sine of 30 is the same thing as cosine of 60 because you change your perspectives, you end up with the same ratios because what was once the adjacent is now your opposite. The same thing happens here with cosine. They're the same, cosine of 30 and sine of 60, because you end up going to the same sides because cosine is the adjacent side to 30, and that is the square root of 3. But that is the opposite of your 60-degree angle, which is what you look at for sine. So it's kind of fascinating, this interrelationship here between them. Another special triangle is the 45, 45, 90 triangle. And sine of that is, when you rationalize, the square root of 2 over 2. And it's the same for cosine because the two legs are the same length. And tangent is just going to be 1 because, well, if you go opposite over adjacent, it's 1 over 1, which is 1. All right. Part of this lesson is being able to actually apply these trig ratios in real life and see, okay, why do people study these? Okay. Most often when we're working with these right triangles, it's due to the fact that we have these angles of elevation or angles of depression. And that happens when, okay, you have a person, okay, if we're looking at the angle of depression, that's up here. You have a person at a certain height or an object at a certain height, and the angle of depression is going to be from that horizontal line of sight downward. And that would create a right triangle there. An angle of elevation occurs when you are looking out at a horizontal, but then your line of sight is inclined. That's an angle of elevation going up and depression going down from a horizontal. Let me show you what this looks like. From a spot 75 feet from the base of a building, an engineer is using a transit, which is a tool used to determine the angle of elevation, so looking up to the top of a building. And that angle of elevation, it measures 67 degrees. If the transit is actually 5 feet off of the ground, so it's 5 feet tall, what is the height of the building? Okay, one of my catchphrases is, when in doubt, draw it out. We're going to sketch a diagram here. And here is my lovely diagram. Okay, so there is the person with the transit. Kind of looks like a telescope, but it just doesn't go quite looking at the stars. Okay, so it is 5 feet off the ground. That's why it's elevated off the ground. And you'll see that there is okay, so it's horizontal. That would be with no angle. To the top of the building is a 67-degree angle of inclination. And what we're trying to find is the height of your building. Now you see that 75 feet, that's supposed to represent how far away the transit is from your building. Okay, that's why it's scooted away from your building. So, of course, this is not drawn to scale very well, but let's write a ratio here. We're looking at x and 75. Those are the measures we know in that kind of right triangle that's been created. And we're working with the angle of 67. That is opposite. X is opposite, and that base is 75. That is adjacent, so it's a tangent ratio that we're working with. And so, like we've done in this video, we can solve for x. To do so, you could just multiply 75 on each side so that your x is isolated, and you could type that whole string, 75 tangent 67 degrees, into your calculator, and that will give you 176.7. Okay, so what does that mean? That means that the measure of x of that triangle, that right triangle, is 176.7 feet. But we can't forget that we need to include that 5 feet that the transit was above the ground to give the true height of your building. So the building is actually 181.7 feet high. All right, so we're going to work through more of these together. If you had questions, please write them down. I would love to answer them. Until we meet again, have a good day.